To simplify this complex fraction, you need to separate the top problem and the bottom problem to find those answers first. The top problem is 1 plus 3 over x minus 2. So we want to write that as 1 over 1 plus 3 over x minus 2. Next, we're going to multiply by what's missing. The first denominator has a 1 and the second denominator has an x minus 2 group, and that group does not factor. We have to get a least common denominator. So I'm going to multiply the first fraction by the x minus 2 group and the second fraction by the 1. And whatever you multiply on the bottom by, you have to multiply also on the numerator. So when we simplify this, we write fraction plus fraction. My denominator is x minus 2 times 1, so it's just x minus 2. And my numerator simplifies with the first one. I distribute the 1 times x minus 2 to get x minus 2. And in the second fraction, 3 times 1 is 3. So now I'm going to add these together, and I keep the denominator x minus 2, and I link together the expressions going from left to right. So I have x minus 2 plus 3. That equals x plus 1 over x minus 2. Now we've learned that we cannot cancel the x's because they're part of a binomial group. They're protected. So this is as far as we can simplify that top expression. It's x plus 1 over x minus 2. Now the bottom expression is 1 minus 3 over x plus 2. So we have 1 over 1 minus 3 over x plus 2. The procedure here is the same. We're going to multiply the first one by the x plus 2, top and bottom. Second one gets the 1. We simplify, we get x plus 2 over x plus 2 minus 3 over x plus 2. Link it together from left to right. So we have x plus 2 minus 3 all over x plus 2. That simplifies on the top to x minus 1 over x plus 2. So I have my top answer and my bottom answer. And what we're doing with these is it is a complex fraction, so we're dividing these two expressions. So it's the top divided by the bottom answer. Or it's x plus 1 over x minus 2, that was my top expression, divided by x minus 1 over x plus 2. When we divide fractions, we multiply by the reciprocal. So I get x plus 1 over x minus 2 times x plus 2 over x minus 1. Multiply straight across, and these groups don't cancel, so I have x plus 1 times x plus 2 over x minus 2 on the bottom times x minus 1. So this would be my complex fraction that I have. Now you can, since nothing canceled, you can double distribute and FOIL this out. So you would get x squared, you do your x times x times 2 is 2x, 1 times x is x, and 1 times 2 is 2, all over, do the same thing down there, x squared minus x minus 2x plus 2, and then add like terms. So you get x squared plus 3x plus 2, all over x squared minus 3x plus 2. So you could do a final answer like that on ALEKS. On the test, you can do this factored expression as your final answer.